Today we will be introducing you to the Chalice volcanoes. We plan to apply our lessons from Geology 100 to further explain our research. First, we will explain where the Chalice Mountains are located. Then we will go on to talk about the history of the volcanoes. We will discuss the dating techniques geologists have used to trace the age of the volcanoes and rocks. We will go on to explain the types of rocks found in the Chalice region. This includes both sedimentary rocks and igneous rocks. We will explain the geological features of the Chalice region. Some of today's well-known features include traces of glacial features, which have directly shaped the topography of the area. Lastly, we will explore the natural hazards and natural resources of the Chalice volcanoes.
The Chalice Volcanic Province is 25,000 square kilometers of forestry and rock. The Chalice Volcanic region are located in the middle region of Idaho. They are accessible coming from all directions in Idaho. In proximity to our community in Boise, the Chalice Volcanic Group lies northeast of us. Let's compare the location of the Chalice volcanoes to some other geological structures. The Chalice volcanics are directly south of the Belt Series province. They are located north of the Hawaii volcanics and the Snake River Plain. The Chalice volcanoes are part of the Eocene belt. In fact, it is the largest part of the belt that contains volcanic rocks. The majority of rocks formed 56 to 33 million years ago. Most of the volcanic eruptions took place between 51 and 45 million years ago. Chalice volcanics are a great place to study igneous rocks. It is also a great place to explore natural landforms and how they have come to be.
Normal faults have shaped much of the land in the Chalice region. There are a combination of low-angled normal faults and high-angled normal faults. They have a tendency to dip towards each other. This creates many hillsides and basins. The Trans-Chalice Fault Zone plays a major role in the geologic structure of the Chalice volcanoes. During the beginning stages of movement, the Farallon Plate was subducting beneath the North American Plate, making it a normal fault. At this time, the angle of subduction was shallow. A new stage of movement for the Trans-Chalice Fault begins 56 million years ago. The angle of the subduction became steeper, and the rate of the subduction slowed down. The Farallon Plate, which was subducting, moved west. One result of this plate movement was the formations of basins in the western region of the Chalice volcanoes. Igneous bedrock formed and settled in this region as a result. Most of the rocks are dated through radiometric and stratigraphic dating. An example of stratigraphic dating is cross-cutting. Cross-cutting is used to show different layers and determine the age of rocks. Igneous rocks are part of the Eocene group. These rocks have formed from 52 to 39 million years ago, when the Chalice volcanoes were active. The igneous rocks we will go over today include tuff, rhyolite, andesite, basalt, and granite. This is evidence that most of the Chalice region consists of igneous rocks. The first igneous rock we will be discussing is tuff. Tuff is pyroclastic in composition, with varying textures and colors. Tuff often refers to volcanic ash. It is created during the cooling stages after volcanic eruption. The second igneous rock to make up the Chalice volcanoes is rhyolite, which is an extrusive rock. Volcanoes erupted and then lava flowed and cooled on the outside surfaces of Earth. This is how rhyolite was formed. It has a felsic composition and an aphanetic texture. Andesite is another example of igneous rock that can be found in the Chalice region. Andesite is intermediate in composition. It varies from aphanetic to porphyritic in texture. The Little Wood River cuts through layers of rock to expose traces of andesite, both extrusively and intrusively.
Next, Basalt is an extrusive igneous rock. It is aphanetic and usually gray or black in color, so it is mafic. Basalt is high in iron. When the water reacts with the iron, it will give off a rusty brown or red coloring. Weathering can change the appearance and coloring of basalt. The last igneous rock is granite. This rock is formed underground, making it intrusive. Granite is felsic. There are small traces of granite in western part of the Challis region. The western Challis border neighbors the Idaho-Batholith region, which is high in granite. This explains the placement and small abundance of granite in the Challis region.
Some well-known features of the Challis region include Little Wood River and Thunder Mountain. Little Wood River has helped shape the topography of the land. The river feeds into the well-known Idaho Falls, a very scenic destination for many. Thunder Mountain is a recognized feature in the Challis volcano region as well. Thunder Mountain is located on the Eocene belt of the Challis volcanoes. The region has steep slopes. There are rivers and streams at the bottom of valleys. As a result, the valleys around Thunder Mountain are V-shaped. Geologists have found that volcanic eruptions took place 50 million years ago. Thunder Mountain is considered to be rather young. Ash flow and lava flow created layers of crystallized igneous rock. This created the base of Thunder Mountain. Thunder Mountain also features a caldera, which is a volcanic crater. This formed from rhyolite ash flow that became confined in a circular fashion.
Glacier features still stand today in the Challis region. The Challis area was once glaciated during the Pleistocene period. This has created horns where three peaks come together, usually surrounded by cirques or bowl-shaped features facing down the mountainside. U-shaped valleys form as a result of cirques. The history of the land really changed during this time period, which has formed and sculpted the topography in the Challis volcanic regions today.
There are several natural hazards in the Challis region. Like most of Idaho, the forests of the Challis region are extremely prone to wildfires. Being a desert landscape, wildfires are common throughout the dry, hot summers. Another natural hazard specific to the Challis region includes earthquakes. The Challis region is the most common place in all of Idaho to have earthquakes. There are high measurements of seismic activity here. These earthquakes can directly affect local towns in the area. It is important to monitor earthquakes in this area in order to maintain safety. In the last few months, the Challis volcanoes have had several earthquakes.
Rockslides are another hazard to look out for in the Challis volcanic region. It is not uncommon for mountain roads to experience severely dangerous rockslides. The Challis area is historically home to gold and silver mining. Thomas Creek Mining Company is located in Challis, Idaho. They are currently focused on mining ores and materials, which they ship out in return for profit. Logging and timber production is another industry that is found in Challis. According to Idaho State's timber industry, 40% of Idaho is covered in trees. Due to abundance of forestry in the Challis region, it is only logical for us to take advantage of this resource. This will continue to be a growing and thriving industry in Idaho for many years to come.